this meeting, and yeah, based on the quality of the recording, we might post it online later on. So the plan is to actually host a virtual user group once a month, and every fourth month or so we'll probably have an actual meetup. We are really looking forward to the feedback you'll have after this session. We'll probably send a survey in the next couple of days. Both myself and Adam and Josh, actually, we all went to the PowerShell Summit in Seattle early this year, and I have to say it was a very good experience. Really enjoyed it. The highlight for me was actually meeting Jeffrey Snover in person. That was pretty good. So yeah, and I guess before any further ado, I'll hand over to Adam. Adam will be covering PowerShell tips and tricks. So we decided to probably start with a bit of a beginner's session, and then yeah, we'll hopefully have a bit more advanced stuff for you guys as well in this meeting. Alrighty, over to you, Adam.
Hi guys, welcome aboard. So yeah, as Charbel said, my name's Adam Murray. Charbel, myself, and Josh were all in Seattle in April, and we were talking about how underrepresented Australia and New Zealand was in the PowerShell community. So we decided that we needed to get a user group up and running. So we actually hijacked this user group and kicking it off again. So I'm just going to spend a few minutes and I'm going to go through some basics in PowerShell, just as a refresher for any of you more advanced PowerShellers, and an introduction for the beginners out there. So where should you start with PowerShell? Well, probably get help is a pretty good place to start. So PowerShell has quite an extensive help system that is built in. So the command I just ran is the default get help command, and it actually gives me help about get help. As you can see, it actually streamed a lot of content onto my screen and didn't page that information. So what I can actually do is, instead of running get help, I can run the command help. So help is actually a function for get help that pipes the content to more. So it pages the content one page at a time. So now I can scroll through the content one page at a time. If I want to actually have a look at how help is different to get help, I can actually have a look at the definition of that function. So this command I'm about to run, I'm going to do a directory, or I'm going to get item function help, and then I'm going to look at the definition. So what you should be able to see, there's some parameters up the top, but basically all it's running at the end is running get help and piping it to more. So that's a bit of a secret for how you can have a function that wraps a commandlet. So now if we want to get help about another commandlet, so invoke web request is very helpful. So now what it's given to me is just some basic information. So here you can see synopsis, syntax, description, related links, relinks, and remarks. But that's not all the information that's available for help. So if I want to run the same command again, and I can do full, so now what I'll see is actually details of the parameters. So there's quite a lot of parameters, so I'll just page through these and keep going. I get inputs, outputs, notes, and then I get examples. And what you can do with the help system is you can choose any part of the help that you want to display. So for example, if I want to do just examples, I can just specify examples and I just get examples. Out of the box, when you install PowerShell, you don't actually have the help files locally. So PowerShell, since version 3, has had this concept of updatable help. So there's actually a command called update help that you can run, and it will go to the internet and it'll retrieve the latest help. There are some caveats. It needs to be run as an administrator because it's actually updating help in some of your System32 and some of your privileged areas. So the first time that you want to use help, just make sure you run as administrator and do update help and give yourself a couple of minutes for it to update everything. The other thing you can do is, so if we want to run get help, so whether I run get help or help doesn't matter, but I can do invoke web request again, and this time I want to do online. So what this actually did, and you're not going to see it because I'm not sharing it. Just share this for you. So that launched my web browser, and it actually took me to the help document that is online. Can everyone see that one okay?
Yep.
Okay, sorry. Rightio, the other, so we'll just jump back to the PowerShell window. Might be easier if I share my desktop. Okay. Okay, hopefully you can see it again. So in Windows PowerShell, I can also run a command which is called show window. And what that does, it just gives me a dialog box. Well, it's actually essentially using the ISE in the background, but it displays the help that I can scroll through as well. This feature isn't available in PowerShell Core, as PowerShell Core doesn't have any WPF UI type elements. The other thing with help is it can run against aliases as well. So the alias for invoke web request is IWR, well, that's one alias. So I don't need to type the full command if I know the alias, and it'll actually return me what the full command is as well. So next, I want to quickly show you about using get command. So this is another fundamental when you're learning PowerShell and even as an advanced user. So the first thing we want to do is have a look at the help for get command. So what it does, it allows us to search the system for modules, functions, executables, essentially any commands that we could execute on the machine. So I can use an alias for get command, which is getCM, and I can go get me all the processes that start with get star. So on my machine, I have a lot of modules installed, a lot of Azure modules, so that brings back a lot of commands. So we'll just kill that. But then I can also run star process star. So this will return all the commands on my machine that contain the word process. That's a much more manageable list. The other thing you can do is, so for executables, so I have .NET installed, the .NET SDK, so I can do get command .NET. And what this actually does, so I can then see the path to where that executable is on my machine. So this will only return executables that are within the path on your system. I can do verb and specify the verb that I want to return commands for. So I chose block because block doesn't have too many commandlets. Just out of interest, if you wanted to know what verbs are supported in PowerShell, you can just use get verb. The other thing I can do is do get command for help itself, and it tells you what type it is. So that's how I knew that when I was running help, it was running a function, and then I could go and look at the definition of that function to see what it was doing in the background, which was running get help and then piping to more. Okay, the next thing we want to cover quickly is get member. So everything in PowerShell is an object, and that's one of the real one of the real strengths of PowerShell. So if we have a look at get member, so it allows us to get the properties and methods of objects that are returned. So generally what you'll do is you'll have an object and you'll pass it through the pipeline. So we're going to demonstrate this now. So this is a string, and then we use the pipe command to pipe through the command line to get member. And it comes back with a whole heap of methods and a property, and we can see that is a type of system.string. So the reason this get member is so important is because as you start piping more commands through the pipeline, you need to understand what methods and properties are available on the objects that you're passing through, so that you know how to act on those. So let's just store our string in a variable. So we've just assigned it to $s. So now we can pipe $s to get member. The alias for get member is GM, and we can see our properties again. The other thing we want to do is I've now got this variable that contains a string. I can run. So in here I can see there's a method called getType. So I want to run that method. So we're going to do getType, and I can see I'm returning a string. But the other things you can sort of do are, so if I wanted to, for example, return everything in uppercase, I can run this method toUpper. So essentially this is a way of allowing you to understand what you can do with the objects that are coming through. So quite often you can start looking at the members on an object, and you can start understanding what some of the capabilities are that you can do with that object. Okay, so we're going to look at, so I've just got a couple of files in here. I'm going to remove, oh no, that's fine. What we're going to do is store one of these files in a variable. So now if I look at the members on that file, what I can see at the top here is I've got a type of system.io.fileinfo. Now when I look at some of the properties on those, on that type of object, I can see it has a creation time. I can see it has, if it's a directory, if it exists, the extension, the full name, so, and the length. So I've got all these properties that I would expect to see on a file. So if I want to, for example, just look at the name, I can do name, or I can do .length, and I can get the length of that file. But the point I want to raise here is, when I did that directory, I specified one single file. If I do a directory, and directory is an alias for get child item, but if I run a directory against the whole directory, this time I've returned to my file system, into my variable f, 2 objects. So when I do a count, I can see 2. So this time, if I do a getType, I've actually got an object, and these square brackets mean it's an array. So I've got an array of objects that have been returned. But what I'll actually know, what you'll see, if I pipe $f back into getMember, you'll see it has actually returned the file info object and the properties and methods that are available on that object. And the reason that happens is because when you pipe things through the pipeline, PowerShell unravels arrays for you automatically. So as a beginner, it's quite important to sometimes be able to look at the actual type of the object and tell whether it's an array versus when we did a single. And I just had a single item, not an array returned. This generally PowerShell takes care of the things in the background for you, and you don't have to worry about it too much. But from time to time, depending what you're trying to do, it can trip you up. So moving on quickly, the other commands that are very helpful as a beginner is get history. So it shows me my history for this session only. In a moment, I'm going to show you something else that shows you history across sessions. And then from get history, there's another command called invoke history, where I can actually go and execute any of the other commands that I've already run. So for example, 31 is $f equals dir. So if I want to run that command, and now I've looked at $f, I can see that it's run that command again. There are aliases for get history. So ghy is get history, and ihy is invoke history. Okay. So now a bit more powerful is something called PS readline. This was a module that was added to PowerShell a few versions ago, and it actually provides a lot of the additional console user interface that we get. So some of the color coding that you can see here, some of the copy and paste is all handled by this module. There's a command called get PS readline key handler. It'll actually tell you what functions are mapped to particular key combinations. So for example, I can see enter just accepts the line. Up arrow will show me my previous history. Down arrow will show me the next in the history. So that's like going through my get history. The commands I'm going to quickly focus on today are Control R, which is reverse search history, and Control S, which is forward search history. So if I go back down, if I press Control R, I can start typing anything that any command or part of a command that I've run previously, and it'll bring it up interactively. If I press Control R again, it'll keep scrolling back through the commands, showing me all the commands that I've used. The beauty of PS readline is it runs across all your sessions. So it actually uses a text file to store your history on your file system. And you can see that by running, if you run get PS readline option, I can see under my history save path, it actually has a text file. So if I open that up in a text editor, I'll be able to see all my command history across all the sessions that I've run on this machine. The other thing that you've got in here is the colors, so you can play around, set different colors if you want to do stuff like that. One last thing with get PS readline is it does commandlet completion. So if you put a hyphen in on a command, so for example dir is the same as get child item, we do hyphen, I can press Control space, and that will bring up all the parameters that are available, and I can just arrow through those and choose the ones that I want. Okay, so that's a bit of an introduction to PS readline. The other things that I find quite helpful are quite often I want to use the clipboard. So I'm just going to bring up a notepad here. Switch back here. So if I do a dir, say I just want to select the name and the length. So we can see that returned. But quite often I might want to paste some of this onto my clipboard. So I can actually run clip, and then if I go into my notepad, I can paste it. So it's a very easy way to take some content that you've been working off in PowerShell and put it into another application. If I run get command on clip, I can actually see there's a clip.exe, which is the native Windows command line clip, and then there's a get clipboard and a set clipboard. So if I did the same thing and this time did it into set clipboard, and we'll paste the content, you can see I get slightly different output, and that's because the way that set clipboard handles the objects is different to the way clip.exe handles the objects. But for something like dir, I might want to really do something like this, where I just want name, and then I want set clipboard. So if I want a list of all my files in a directory, I could run that command, and then I just get an output with those files. The other thing that I may want to do quite often is export information to a CSV. So this time I want to we'll do the same thing here, except instead of set clipboard, we're going to export to CSV. I always specify no type information. By default, up until version 6, PowerShell used to put a line at the top of your CSV that had the type that it was exporting, but most of the time you don't want that information. And then I can just export that to a file. And then there's a command called invoke item, which has an alias II. So I'm going to run invoke tcsv. And there's my Excel spreadsheet. So I do a lot of work where I'm jumping in and out of Excel, pasting content in, and that's very helpful. So I've pretty much filled up my time, so I was going to pass over to Josh. Is there any questions before I do?
I think Jeb has a question.
Oh, favorite use case for PowerShell. So for me, PowerShell is like the ultimate glue. So I love integrating bits and pieces of information from one system into another. I love actually being able to just take a bit of information or take a task that I might have done manually before and spend a few minutes and see how I can automate that use case in PowerShell. It's amazing how you can come up with some awesome one-liners that you may then convert into a script, because PowerShell gives you that console experience, but then you can also go into a more blown development mode where you're creating productionized scripts. So it's such a useful Swiss Army knife. I think it's an amazing tool. Okay, Josh, over to you.
Awesome, thanks Adam. Okay, I guess I better share my screen. It's a good start. All right, let me know when you can see that.
Yep, that's
awesome.
Good.
Cool. So this is whip your scripts into shape. This is what I presented at the PowerShell Summit in April. And I haven't changed, well, as you can see, it's still on the Summit's template, so not much has changed since then. So a little bit about me. I'm Josh King. You can find my blog at king.geek.nz, and I'm on Twitter at WindowsNZ. And it's not as big of a thing for this. Well, actually, sorry. If you're anything like me and you know people by Twitter avatars, that's me. And it's not as big of a thing here, given that this is the Australia-New Zealand PowerShell user group, as it was over at the Summit. But I'm from New Zealand, so I'm the New Zealand side of the ANZ. And I come from a town there called Hastings, and I actually work for the local district council. And here's a nice shot of our town. So, the topic of this talk is summed up as speed in PowerShell. Unfortunately, PowerShell does have a bit of a bad perception in the speed department, and that's possibly thanks to startup times, because let's be frank, if your first experience jumping into PowerShell is it taking 2 to 5 seconds to open up the console, that's probably going to tar your opinion of it going forward. And it is a pretty common complaint. So this screenshot was taken last year sometime, and over 500,000 results. Not a good picture. So, to measure speed, we're going to be doing some A/B testing. And I'm bastardizing that term a little bit. But what we'll be doing is we'll be taking a control, which is one way of doing something in PowerShell, and then comparing it against a different way to do that same thing in PowerShell, and we'll see what the differences are. So A/B testing is all about measuring, and if you're looking for improvements, you've got to measure it. There's no point trying to optimize something if you're not quantifying the changes that you're making. Do only make one change at a time, and this applies to most things in IT. So my normal example here is if you've got a network issue, you don't go ahead and replace your patch leads, your fly leads, your switch, your network adapters, your drivers all at the same time, because one of those things probably fixed your issue, but you're never going to know which it was. And test it more than once. We're going to be dealing with a lot of random variables. Some of the tests I'll be showing tonight are very, very close, and the results can depend on the way the wind's blowing. And also, when you're taking measurements, it is going to impact performance a little bit. So you've got to try and minimize the impact of your observations against your test cases. So my tests are going to be handled by a module called RunBucket. This is actually a link that you can click. It's on GitHub. It will be up on the gallery soon. But this is a module that simply takes a control, which is a script block of one way to do something, a variation, which is another script block, and runs it a bunch. So a little bit more about RunBucket. Behind the scenes, it's using Posh RSJob, and that's so that we can run a lot of test cases at once. It defaults to 100 iterations of each test case, and that's both the control and the variance, so a total of 200. The only times that I'm not doing 100 iterations is if it's a long running process and we can't sit around waiting for it to finish up. And just to eliminate any massive outliers, I'm ignoring the slowest and the fastest results, the one of each. And we're looking at, once we've taken those off, we'll be looking at the minimum, maximum, and average. And I talked about minimizing the impact of our testing. I'm using stopwatch here. That's not so much for minimizing the impact of it. This is so that the impact of outputting to the console is taken into account, because measure command will basically silence the output to the console and effectively ignoring it. So if that's what's slowing something down, measure command won't pick that up. And I'm going to be displaying these results via Universal Dashboard, which is a really cool tool to play with. So just to address it, because this is some of the feedback I got when I did a dry run of this at work, is there will be notifications popping up. They're going to look a little something like this, and it's not because I've left Slack open, they're not Twitter messages coming in or anything, they are expected, and you'll see why I need to run them as we go through. Like it says there, this indicates that all test cases are finished, and they're created via my Burnt Toast module. So let's look at some code. Before we really dive in, I'm going to be looking at 10 concepts, and these are comprised in 11 demos. The demos may have unexpected results in that they may not end up with the results that I'm expecting, and that's sort of the point, and something that we'll drive through in the takeaways. I'm using numerous Visual Studio Code and PowerShell tools. And if you're interested in any of the mechanics about how this is working, hit me up on Twitter later and we'll have a chat. But all of this code is on GitHub, and there's a link at the end of the slide deck. And you won't actually see me running any code. I'm using some commands within Visual Studio Code to pull up my demos, and they automatically start running in the background, and that's mainly so that I don't forget to run them and we have to sit here waiting for them to finish. Before we jump in, I'll show you an example of the dashboard. So all of the results in the left and middle columns are in milliseconds, and they're accurate down to the third decimal point. The control and the variation will be designated within the demos, but the control's always first, the variation's always second. And then on the right hand side, we can see the differences. So we've got a minimum, maximum, and average value for each test case. And a minus percentage means that it's run that much faster. So in this example, which is very contrived, the control is actually just running sleep for a couple of seconds, and the variation wasn't. But it was 98% faster. And what's determining the winner is the average rather than the minimum or maximum. So there will be cases where you might see the maximum being red here, but it's still winning. So yeah, I'll talk through each of the results as we come across them. So back to our code, let's pull up our first demo. I mentioned output to the console potentially slowing things down, so that's the first thing we're going to look at. Our control is getChildItem, and we saw Adam running this a fair amount, and I'll call it out this first time. Those tests have finished and they took 7 seconds to run. So getChildItem is by default going to output its results to the console. Our variation is basically assigning those results to a variable, effectively eliminating that output to the console. This one, all of my other demos end up with the same output at the end. This is my only one that doesn't, but I did want to sort of demo this one just to illustrate the point. So if I go ahead and pull up the results, as you can see, running getChildItem, and I didn't show you what folder that was against, but I'll address that when we head back to it. Our control took basically 42 milliseconds, and our average took 37, and our variation took 37. Keep in mind, this is a file system related thing on a relatively small folder, and I'm running it on a pretty fast SSD. So if this was spinning disk, the difference would be different. If we were running it across an entire file server, you know, these differences scale quite dramatically, and the difference being about a 10% improvement simply by not outputting the results to the console. And that folder that we were hitting up was my drivers folder in System32. So, our second one. The first thing we hear when we're learning PowerShell is the adage about filter left, format right. And I think we all sort of understand the concept there, which is you want to get down to just the items you want to be working with as soon as possible, rather than shipping a bunch of data through the pipeline. So our control here is getting a bunch of events from my application log and piping that to where object, where I'm looking for a specific ID and where the time created was within the last hour. My variation is using the filter that's built directly into getWhenEvent. So now getWhenEvent is just getting the events that I'm looking for, rather than getting all the events and then filtering out what I want. So if we look at the results for that, this one's pretty dramatic. And I've specifically pruned my event log so that this isn't too big of a difference, because it can often, this can be multiple seconds and this stays about 14 milliseconds. But our control, which is where we were piping to where object, is 146-ish milliseconds. Our variation cuts that down to 14, and that's 90% faster, which is massive. And roughly that percentage is the minimum and maximum represented as well. So definitely filter left and then do your formatting later on. In a similar vein, you really only want to be touching items once. I'll talk through this example and then I'll talk through a better example which I couldn't set up for this demo, which is, in this example, we're applying what we've learnt about filtering. So I'm using getWhenEvent. I'm filtering for an ID in my application log, and I'm also filtering for an ID in my system log. So I end up with app events and I end up with sys events. Alternatively, I can look for both application and system and both IDs, and for this example I have made sure that this event ID is only present in the system log and this event is only in the application log, and then I'm using the where method to filter out into app events and sys events, so I end up with the same output at the end. The results on this are probably pretty tight, and in fact they are. So like I said, this isn't the best example of this. A better example, which I couldn't get a lab set up for, is Active Directory. So for me, we have our contractors, our users, our service accounts, all in separate OUs, and what we would do if, say, we were generating an audit report is query each of those OUs in sequence, and that could take quite a long time. What's quicker is if I query the parent OU and then filter into the individual variables or the various OUs after the fact. Yeah, so this is one of the ones I was expecting to possibly be a bit closer than what we see here, but that's how it goes. So, verbosity. Adam showed quite a few aliases, and using aliases and writing really short one-liners is a really popular thing to do in PowerShell. You'll see competitions and all sorts for writing the shortest line possible, and that's great and it's really awesome to do at the console, but there is a performance hit. So as our control, we're looking for specific services. We want services that are running, and then we're going to select the first 5 of them. This is using various aliases such as service instead of get service, a question mark instead of where object, and select -F instead of select object minus or dash first. And then our variance is our variation is filling out each of those aliases to be their full representation. So if we look at the difference, that's about a 40% speed up just by expanding out those aliases into their full names. So we've gone from an average of 6 to an average of 3.5-ish milliseconds. Now, one of the biggest ones here, and it's probably makes it not that fair, is this service one. Because what PowerShell is doing in the background is it's looking for a commandlet name service, and it doesn't find one. It's looking for a function named service, and it doesn't find one. It drops down to the file system, and it looks for system.exe, and it doesn't find that. So then it goes, all right, I'll add a get to the start of what you've asked me for, and we'll try again. So then it goes get service, and then it finds it. And I am simplifying that quite a lot, but basically it's doing a lot of work to try and figure out what you want to get out of it before it figures out, you want to use get service. So that is a nice way to quickly type something where you can drop get off the front of a commandlet, but just be aware of the performance hit there. Right, so we've been using the pipeline quite a lot, and it's one of the killer features of PowerShell. But let's try and figure out what the performance hit of using it is. So we'll use our old trusty get child item again. This time we're going to be looking at my temp directory where I've filled it up with a bunch of random text and doc files. And I'm going to use where object to find any that are longer than 5,000 bytes, I believe. And our variation is, instead of piping to where object, we're going to use the where method, which eliminates the pipeline and the commandlet where object. And the difference is about a quarter faster, or 25-ish%. I'm liberally rounding here. But so we've gone from 25 milliseconds using the pipeline down to 19. And that's simply by eliminating the pipeline. So then we start getting into more programmatic things, and we start going a bit loopy. Now, this one does sort of play into the pipeline thing. This is two different ways of running for each. Now, we're looking at our temp directory again, running get child item, and we're going to be totaling the lengths now. Now, this for each after the pipeline and this for each look very similar, and that's more because of how I've written it than anything else, because that for each is actually an alias for each object, a commandlet, whereas this is for each a statement or a statement within the PowerShell language itself. And this does, unfortunately, sort of lean into the fact that the pipeline has its own performance impact as well. But I really wanted to drill in the different ways of doing a for each loop. And the difference here is about another 0.25% speed up. A little bit more this time. And unfortunately, it's hard to know how much of that is the pipeline itself or the overhead of a command versus a statement within the language. But just know that the for each, when you can use a for each statement rather than the for each commandlet, you're going to get a speed improvement. Now, this is one that may be a little tight on the timings as well, but it's doing unnecessary operations. And again, this is one that's maybe not the best example for this, but it's a neat trick that I ran into recently when I was doing a software deployment. So I needed to know what version of something was installed on my machine versus a version that I was planning on installing. So to demo this, I'm using the PowerShell version, and if you're not sure what that looks like, it's in your PowerShell version table, and it comes out looking a little something like this, where you've got the major, minor, build, version, blah, blah, blah. And I want to test it against this string. So thinking through the problem, I go, oh, okay, I can split this on those periods, so I do that. And then I construct this if-else sort of tree, where if the version coming out of that is greater than or equal to what I've split out of here, all the way through my tree, I return false. Otherwise, we return true. Otherwise, we'll return false. So probably a smarter idea than that is to just cast my string as a version object, and then I can compare them directly. So as it says, is this operation necessary? None of that was necessary when you know that you can cast your string as a version and just compare them as objects directly. Of course, you have to know that you can that there's a version type available to use before you can eliminate those unnecessary operations. And hopefully, and in this case it's not, and hopefully it's faster. Like I say, this isn't the best example, but that being able to cast as a version was kind of cool, and I wanted to show it. But like I say, the margins here are tiny. We're dealing with 0.4 milliseconds in each case, so I could have had my foot up on my computer and it would have made a difference because it was slightly warmer. Who knows? But on to some of the more meaty ones. It's time to get naked. So PowerShell does a lot of work to make your life easy. It's running on .NET, but it's obfuscating a lot of that from you. So, for example, there's this handy new GUID commandlet, and at the end of the day, that's giving you the same thing that the GUID.NET type gives you. So both my control and my variation end up giving me 1,000 new GUIDs, and the output of this is exactly the same. It's just the difference of running a commandlet versus the naked .NET. Other examples of this could be using I always forget the name of it, but there's a .NET class you can use for pinging a remote machine as opposed to using test connection. And you should see similar results. So in this case, using new GUID to generate 1,000 GUIDs gives us 82 milliseconds, as opposed to using the .NET class, which takes it down to 2 milliseconds. So that's a 97.5% decrease just by going with the naked .NET rather than a commandlet. And of course, same with knowing that you can cast a variable as a specific type. It does require you to have a bit of knowledge of .NET there, which I guess may be a case for learning a bit of C#, so you can pull that over to PowerShell. But yeah, it's one of those things, if you know it and you're okay writing it, go ahead and use it. Now, collections. You'll often see this sort of construct here, where we're generating an empty collection or array, and we're going to, in this case, generate about 1,000 random numbers. Each of those random numbers could be anything between 0 and 1,000, and we're going to put each of those into a collection. So we're creating a collection variable, and we're using the plus equals operator here to assign each of these random numbers to that collection. Variation is using an array list, and then rather than using the plus equals notation, we're using the add method, which is comes with the array list. but the end result's the same. We're going to end up with 1,000 random numbers. Do note that at the start of this line I've got a null equals. That's because that add method outputs the index for the item that it's just added to the array list. And because the plus equals doesn't do that, I'm silencing that so that the output both to the console and our variable is the same. There's a few ways to silence output. I'm using null equals. I think you can cast it as a void type as well, or you can pipe to out null, but as we already discovered, piping is not good for performance, so we're obviously not going to do that. And this is just the method I tend to lean on, so that's what I've used here. So, a standard collection with plus equals versus an array list using the add method. The difference is massive. I think this is one of the biggest differences that I consistently get in all of these test cases. So the standard collection / array is about 66 milliseconds versus less than 1 for the array list. And obviously this is just doing 1,000 items. You scale this out to 10,000, 100,000, it gets massive. But, of course, once you've become a collector, then it's time to become a hoarder. So, collections are a hotly debated thing out there on the Reddit and the Twitter. So, our control here is our variation from the last example where we're using an array list and the add method, and I've just noticed I haven't assigned that to null, which is naughty of me. But the difference is, another way of assigning the output from a for each loop to a collection is just to assign it directly to the collection. So in this case we're going collection equals and then directly into our for each loop. And forgive me while I rerun this just so it takes into account that null equals. I think why that was missing is because I started playing around with it on stage at the summit, so that ended up getting saved back to the source code, which is always fun. So the difference is, there is a difference, but given that we're going from 0.8 milliseconds to 0.6, I personally prefer this notation, using an array list and using the add method, because I feel like I've got some more control over the whole operation. It's just a personal preference thing, so this is one of those ones where I go, yes, I know there's technically an improvement to be had, but I prefer doing it this way. Also, you might run into memory issues if you do this with an absolutely massive collection, possibly. But we'll cover that a bit in a sec. So, our final demo is parallelization, and I always mess up that word. But this example is taking 8 hosts out on the internet. So we've got Google's DNS servers, the new Quad 9's DNS server, and a random news site in New Zealand, stuff.co.nz. We're going to go through each of those, send it a ping twice, and we're going to return an object with the IP address and whether or not it responded. Now this, because of how this is written, we're going to ping each target in sequence. We're going to output the result of that echo request and then move on to the next one. Obviously that's perhaps not as efficient as it could be. So if we instead use PoshRSJob, we will pipe each of those targets into start RSJob. And what this is going to do is it's going to do each of them in parallel. So the example I like to use of this is a supermarket. So say we've got 4 customers in the supermarket, they've all got their trolleys full of groceries, and they head to the checkouts, but there's only one checkout open. So each of those customers take a minute to process. So, the checkout operator is working as fast as they can, and it's going to take them 4 minutes to get through everyone. But let's say they opened up 3 more checkouts. There's 4 open now, which means all 4 of those customers can go through at the same time. It's going to take a minute to process all 4 customers rather than taking 4. So this example mathematically should be about 75% quicker. There is a little bit of overhead in standing up those jobs, so it's not ever quite exactly that, but that makes sense. Thinking of the supermarket analogy, we're pinging 4 hosts, we're sending 2 echo requests. In theory, if we do all 4 in sequence, it should take about 4 times as long as doing all 4 at the same time. Now this is a pretty simple example because we're pinging 4 hosts out on the net. Where I use this a lot is and thanks guys for sharing those links in chat, that's awesome. Where I use this a lot is doing things across multiple servers in our environment. So we've got a couple of 100 servers, and I can do actions on them 25 at a time. Just if you're not using Posh RSJob or some other way to parallelize your jobs, do it. There's no point sitting around waiting. So that's the last of our demos. Let's head back over to PowerPoint. And then the question after all of this is, are these examples a silver bullet? And given the fact that some of the examples didn't turn out how I would have wanted them to, the answer is probably no. So in reality, going through this, you could run into memory consumption or CPU bottlenecks, which you're not going to know until you're processing your own data. When you're optimizing for speed, you might break a working script. And your environment's a snowflake. So I know what works well in my environment through trial and error and, playing. But I don't know your environment. You might have things that work better for you than they do for me. And the takeaways. Don't assume, or as I tried finding a good picture of, don't be a stick in the mud. If you know of one way to do things, don't assume that's the only way to do it or it's the best way to do it. Do try alternatives. Just give them a go and test them. Measure twice. I've run these test cases a lot now, and every time I run them, the results are different. And I've done my best to try and eliminate as many of the variables as I can, and I'm running them 100 times, and I'm doing all of that. But still, I end up with differences. And revisit. One thing Microsoft does really well is pushing out updates and forcing restarts. And that. So you never know if something you've tested today might be changed in 6 months, a year, 2 years. So keep all your test cases in a folder and rerun them once in a while and see if anything's changed. And this is big. Worry about optimizing after it's working. Write the way you are comfortable writing, and worry about looking for optimizations later. You don't want to be hitting yourself up against a brick wall because you're not quite implementing an optimization correctly, and dealing with the script not working, and it becomes a mess. One of the biggest things as well is test your code. During the summit, I plugged a pest session that was on after mine. Obviously, I can't do that now, but there's plenty of resources out there. This is key for that point on the previous slide, which was you might break an existing script. If you've got good test coverage, you should know pretty quickly if you've broken something, if you've got your tests there checking your code. And that's the end. Obviously, you won't be able to rate this this talk via the shed, but the slide deck and the demo code's available there on Bitly. It's also on my GitHub. Well, sorry, that Bitly link points to my GitHub, but failing that, you can always hit me up on Twitter. Yeah. Thank you.
Cool. Thanks for that, Josh. Thanks everyone for joining. We really look forward to getting some feedback and see if you guys really enjoyed this virtual meetup. If you have any topic suggestions, please ping us on Twitter. Our Twitter handle is on the meetup page. And we'll stick around actually for a bit longer if you guys have any specific questions for Adam or Josh to answer on their presentations.
Yeah, thank you all for tuning in. It was good to see so many people here tonight.
Yes, thanks guys. We're looking forward to the next opportunity to present to you guys, and definitely if you've got suggestions or if you're interested in presenting, drop us a message on Twitter and we can see what we can make happen.
And actually that time slot that Adam talked in at the start is a great way to get your feet wet if you're if you don't want to commit to doing a half an hour to an hour presentation and you just want to do 15 minutes or so, put your hands up for that as well.
And don't forget, PS Conf Asia, the tickets are on sale as well. So if you're at all interested in going to a good conference about PowerShell, check it out.
It's a lot closer than the States. By a little bit.
And it'd be good to have quite a few Australians represented.
Yes.
That's right, Jap, and it's cheaper.
And New Zealanders, of course, Josh.
Yeah. And actually, Glenn, I think it was your talk I plugged at the end of my session.
Cool.
Okay, thanks guys.
Thanks everyone. We'll send a survey in the next couple of days, and yeah, please ping us on Twitter in the meantime. Cheers.
See you later.
Thanks everyone.
Thanks everyone.